Okay, good day students. Welcome to Lighted Brains online tutorial. I will be your host for MTH 102. My name is James Otto. Introduction to Differential Calculus. Now, what is calculus? I believe you guys have been taught integration and differentiation in your secondary school. Yeah, I'll be refreshing your memory. Now, calculus is simply the rate at which quantities change. But we won't be using quantities because we are not talking about economics. This is not an economics class. This is a mathematical math class. So we're replacing quantity with what? Function. So we can say that calculus is simply the rate at which functions changes. Okay. Now, what do I mean by function? Now, this is mathematically, function is something like y is equals to what? F of x. F function x. Okay. Now y is equals to f of x. Now this is what we mean by function. And what is a function? I can explain function to you. For you to understand function, let's just look at it this way. A function is like a box or a machine. Okay. Now whatever we put in that machine, is the machine will process it and what gives us information. You know that a computer, whatever it gives it data, it processes the data and what gives out the data as what it already processed data as information. This is what a function is. This is y, and y is known as the dependent variable. Y is a variable, x is a variable. But this one is depending on this one because whatever you put here gives you this. Okay. Now let's take for example your computer. Whatever you give to it, it processes it and gives it out. Okay. So if you don't give it data, if you don't give it something to process, it cannot process and it cannot give you information. Okay. So this is the dependent. This is what independent. Now let's take for example this. Now this is what we are going to be using to understand what calculus really means. Now there are different terms, or there are different methods we use to solve a calculus problem. Let's say for example y is equals to let's say y is equals to 2x. You already know how to differentiate. Let's look at differentiation. You already know how to differentiate. From your secondary school, you were told that okay, this is carrying a power. Let's say okay, let me just use y is equals to 2x squared. This is carrying a power of 2. Now the easy way, using the power method, the easy way to differentiate is well, you use your power to multiply your coefficients. This 2 is called coefficient. You use your power to multiply your coefficients, then you subtract 1 from your power. Using the power rule, y is equals to 2 times 2, then x minus 1. Using your power rule, the power will multiply the coefficient, and then you subtract 1 from the power. So when the power, which is 2, multiply the coefficient, which is 2, you have 2 times 2. And then you subtract 1 from the power, which is what I did here, 2 minus 1. So y will be equals to what? 4x raised to the power what? 1, or which is 4x. So it means that when we differentiate y is equals to 2x squared, we'll be left with what? Y is equals to what? 4x. Very simple and very easy. Using this method is what we call power rule. And you can only apply this method when your exam is what? Multiple choice question exam. Yes, for like delsu 100 level exam, your exam is multiple choice question. You can use this method to solve all your problems that has to do with differential calculus. Fine. But what if your exam is a theory-based exam and you are specifically given what method you have to use to solve? Let's say for example they ask you to use the quotient rule, or use the chain rule, or use the product rule to solve a particularly given differential problem. What then do? You'll be stuck. So that is why it is very, very important to know all the methods of solving. So in this chapter, we'll be looking only at what? We'll be looking at the first principle. The first principle. Now, why do we call it? We don't call it first principle because it's not necessarily because it is the first rule of solving differential problem. And it is actually one of the first, but not really the first. And that's not the reason why we call it first principle. Okay. Now we call it first principle because dy dx, which is dy dx, was derived using the first principle. Okay. Now I'm going to teach you what the first principle is. It's very easy and very, very simple. Now let's take, for example, let's take this expression. Let's say y equals, okay, let's use the first, no, let me just say y equals to 2x. And we were asked to solve to differentiate this expression using first principle, what do we do? Now, this is what you do. Remember the definition of calculus where I said it is the rate at which the rate at which what function changes, right? Now, what does change mean? Change in y means this. What does change in x mean? Change in x means this. And what does this mean? This means y2 minus y1. Let's say for example, this year the product of the amount of chocolates was like 20 naira. Next year it became 40 naira. Then they ask you what is the change? Which means they're asking you what is the change in the amount of milk of chocolate this year and next year. So it's going to be 40 naira minus 20 naira, which will give you what the change. So then let's look at this. Change in y means y2 minus y1. Change in x means x2 minus x1. So now let's look at this. First principle, the first thing for you to do is to add change in y and change in x to both sides, okay? Now this is y equals to 2x. We are going to add change in y to this particular part and what change y to this particular part. So now this is y plus change in y is equals to 2x plus change in x. Now, just look at what I did here. This is y plus change in y equals to 2 bracket x plus change in y. Meaning anywhere I see x, I add change in x. Anywhere I see y, I add what? Change in y. Okay? Very, very simple. Now, the next thing to do after understanding this aspect, this particular thing, the next thing to do is to subtract. This is equation 1 and this is equation 2. We are going to solve more examples. This is equation 1 and this is equation 2. So the next thing to do is to what? Subtract equation 1, EQN, equation 1 from EQN, equation 2. So meaning we are subtracting this from this. Now let's subtract. This is y plus change in y minus y is equals to which is this one, 2 brackets x plus change in x minus what? 2x. Very easy. Subtract this from this, and that's what we are doing. This left hand side, which is the only thing that is there is y. We are subtracting y from this, which is this here. The only thing at the right hand side is 2x. We are subtracting 2x from this particular place here, which is why I have minus 2x here, okay? Now, what do we do? This is y, this is minus y. They can cancel out. Can anything cancel out here? Not really, except we will expand. So in this particular place, we are having change in y only equal to, if I expand this bracket, I'll be having 2 times x, which is 2x, 2 times change in x, which is plus 2 change in x, okay, minus 2x. Can anything cancel here? Can anything cancel? Look at, just take a look at it. Can anything cancel here? Yes. This is minus 2x, this is 2x. So what are we having here? We're having change in y is equals to 2 change in x. Alright, so this is change in y is equals to, the only thing that is left here is 2 change in x, okay? 2 change in x. Now, let's go up there. Okay. Now, we have, don't forget that I said when I was explaining calculus, see, you see this course, this math 1 and 2, it's not all about solving. No. In fact, you are not even going to solve a lot. You'll be asked some theoretical questions, some mind questions. Like you will see questions like maybe they will define what calculus is. Then they will give option and be like, which of this is wrong about calculus? Okay. Now, don't forget that I said that calculus has to do with the rate at which function change. Okay, function. Now, in a function, we have y and we have x, okay? So the rate at which the y variable changes with the x variable. Now, this is change in y and this is what change in x. So how do we get the y over the x, which is the same thing as change in y over change in x? How do we get this? Look at this. How do we get this dy over the x is same as change in y over change in x? We have change in y here. How do we get over change in x? What do? We simply divide both sides by change in x. So this is change in y over change in x. We are dividing this side and this side by changing x is equal to 2 change in x over what? Change in x. Change in y over change in x is equal to 2 change in x over what? Change in y, which is same as dy over dx. Yes. Now, this is change in x, this is change in x. It can cancel out. So it means that change in y over change in x is equal to what? 2. Change in y over change in x is equal to 2. So it means that from this expression, if I differentiate this expression, which is y equals to 2x, if I differentiate it, what I'll have is equal to 2. Now we are going to test that. Using the power rule. Using the power rule. Now we've done the power rule before. So let's verify if we differentiate this, we are going to have 2. Let's test that verification. Now remember I told you that in the power rule, what you simply do is you use the power to multiply the coefficients and then you subtract 1 from the power, right? This is y equal to 2x. What is the power of x here? The power of x here is 1. Yes, you are not seeing it because it's not really necessary to write 1, but there's 1 there. So 1 times 2, I'm saying y is equal to 1 times 2, x 1 minus 1. Why did you subtract 1? Because that's the rule. Whenever you use the power to multiply the coefficient, the next thing to do is to subtract 1 from the power, okay? That's why I'm subtracting 1 here. So what do you get when you multiply 1 times 2? Y is equals to 1 times 2 is equals to what? 2. This is what? X raised to the power what? 0. X raised to the power what? 0. 2 times x raised to the power 0. Now, don't forget that the law of indices states that anything raised to the power 0 will give you what? 1. Even if it's 1 million raised to the power 0, it will give you 1. Even if it's me raised to the power 0, it will give you 1. So x raised to the power 0 will give you what? 1. So it means that y is equals to what? 2 times 1. And 2 times 1 is equals to what? 2. So it means that y is equals to 2. So no matter method we use, whether first principle, whether power rule, whatever method we use, in solving any differential equation, we are going to arrive at the same answer. Okay. So the reason why this is not actually compulsory for you that is writing a theory exam, a multiple choice objective exam, is because you don't really have to go through this long method to get your answer. You can simply use your power rule, fine. But what about you that your exam is theoretical, your exam is is written, and you were specifically asked to use so principle, first principle to solve? That is why you need to learn this step, okay? So we are going to take a look at another example to fully understand the first principle method, okay? Now, let's take a look at another example. Okay, so let's say, for example, y is equals to 4x squared. Now, let's differentiate this. First of all, we are going to use first principle here, and we're going to use the power rule to solve. You will see that we arrive at the same answer. Okay. Now, let's say y is equal to 4x squared. Y is equal to 4x squared. Now, in this part of the board, we'll be solving with first principle. In this part of the board, we're solving using power rule. Now, let's solve using the power rule first of all. Now, you know that the idea or the law using the power rule is that the power will multiply the coefficients and then what? You subtract 1 from the power. Simple. Y is equal to 4, okay, 2 times 4, which is the power, times 4, x in brackets, 2 minus 1, right? What do we do next? This is 2, this is 4, 2 times 4. We say 2 times 4 will give us what? 8. 2 minus 1 will give us what? 1. So we are saying that y is equals to, we are not saying mathematically y is equals to 8x. This is power of 1. Anything raised to the power of 1 is that same thing. Okay, so 8x, 8 raised to the power of 1 is equals to what? X raised to the power of 1 is equals to what? X. So if we differentiate this, we'll be having y is equals to 8x. Now let's see if using the first principle, if we have not been saying rubbish since, let's see if we can use the first principle to arrive at the same answer. Okay. Now the first thing to do, like I said previously, is that we add change in y to this left hand side, change in x to to the right hand side, okay? Now, y plus change in y is equal to 4x plus change in x all squared. X plus change in x all squared, right? Now, this is x. It is x that we added the change, x plus change in x. It is in y that we added the word the change, which is what change in y, okay? Now we squared it because x is carrying square here. Now, what do we do next? What do we do next? This is x plus change in x squared. What we are going to do is we are going to expand. It is either we expand first, or we can say let us subtract equation 1 from equation 2. Either which way. It is mathematics. Mathematics not get ojoro. Yes. So look at it this way. This is equation 1. This is equation 2. Okay? Now let us subtract equation 1 from equation 2. This is equation 1. Y plus change in y minus y, okay, is equal to 4 brackets x plus change in x squared minus 4x squared. It's not magic. This 4x squared here, look at it here. Because they said let us subtract this from this from this. Okay? Now, what do we do next? Y, we take care of minus y. So we are left with what? Change in y. Change in y is equals to 4x plus change in x all squared minus 4x squared. Minus 4x squared. So the next thing to do now is, there's nothing we can do here except the next thing to do is what? To expand this. Do you know how to expand? Now, let us expand this. Let us expand this. Let me wipe this off first. Let us expand this in this particular place first. X plus change in x all squared. What this means is there's two of these identical twins. X plus change in x 2 times, which is x plus change in x plus change in x 2 times, and these two, they are multiplying themselves. So this means x plus change in x plus change in x. Okay, so this is what this simply means. Now let us expand. This is how we expand. The first variable here, which is x, we multiply the first variable here, which is x. Okay, just look at where I'm drawing the arrow. X times x will give us what? X squared. This same first variable will multiply the second one here. X times change in x. X times change in x will give us x. X change in x. Don't forget, x times change in x will not give us change in x squared, but it will give us x times x change in x. Don't forget. Now we have successfully used this one to expand this. Now let us use this to expand this. So look at this now. This is multiplying this. Change in x times x. Change in x times x will also give us what? X change in x. See, change in x is something different entirely. X is different entirely. So when change in x multiply x, it will not give you change in x squared, but instead it will give you x change in x. You understand? It's like you are combining this x and the change in x together. Okay. Now we are also going to use change in x to multiply change in x, and this is what you do. This is x. This is change in x, and this is what? Change in x. And when change in x is multiplying change in x, what do we get? It's more like we are having times 2 of this. Okay. This is going to give you change in x squared. This is going to give you change in x squared. Now we have successfully expanded this, and this is what we got. Now let us put this thing we got after expanding this. Let us put it back into the equation. No. So we have change in y is equal to 4 in brackets. Now don't forget that is what we expanded that we got here. 4 in brackets x squared plus x. Okay, now this is x change in x. This is x change in x. When you add both of them, you'll be having what? 2x change in x. 2x change in x. 2x change in x. Plus what? Plus change in x squared. Change in x squared minus what? 4x squared. Very simple. After expanding, collect like term, you put this whole stuff back into this place. Okay, and this is what you get. Look at, just take a look, take a look, a minute and look at it. So after this, what do you think is next? We are having a bracket here. We are having a bracket here. We are having a bracket. Now, we know that changing y is equals to, and let's use this to expand the bracket. 4 times x squared will give us 4x squared. 4 times 2x changing x will give us 8x changing x, plus 4 times this will give us 4 in brackets changing x all squared minus 4x squared. Now let's bring this up. Now the next thing to do is, there's nothing we can do here except we collect like terms. This is minus 4x squared, right? This is what? 4x squared. This one we cancel this one. Okay? We are left with this and this. And now there's nothing we can do here now. There's nothing we can do there. Now, dy over dx is equals to the limit as change in x tends to 0. Change in x tends to 0. What this simply means, let me just tell you what it means. What this means is that whenever you see change in x, you what? Change in x tends to 0. Meaning, whenever you see change in x, you put what? 0. Okay? Now, this is change in y over change in x. Okay? We are dividing by change in x now. Is equal to, what do we have left? 8x change in x. What? Plus 4 change in x all squared. This is the only thing we have left. Divided by what? Change in x. Divided by what? Change in x. Okay? Now, this can also be written as, here will be what? Change in x. Here will be what? Change in x. The same thing. Now, we have change in x here. This we will take care of this. Okay? This is change in x squared. This is change in x. So if this cancel this, we'll be left with what? 4 change in x. Now, the reason why we cancel it is because this is change in x squared, meaning 2 of it, but this is just 1 of it. So when 1 divide 2, we left with what? 1. That is why this one is still here. And that's why this one cancels the square, because we will left with just 1. So we have 4 change in x left. And don't forget that whenever change in x tends towards 0, so meaning wherever you see change in x, you put in what? 0. So if I put 0 here, 4 times 0 will give me what? 0. So everything here is out of the picture. The only thing left is 8x. So change in y over change in x is equal to what? 8x as your answer. And that was exactly what we got using our power rule, where we which was very short. 2 times 4 will give us 8x. Very simple. So you see, that's simply the approach you take for. You can use power rule. You can use first principle to solve any. You can use first principle to solve any type of differential calculus. Okay, if you use it to solve chain rule problem, you can, but it is a very long process, and you can only do that if you want to increase your math skills. Okay, now for your exam that is CBT in nature, you don't actually need this to solve. Okay, you don't need this to solve. Now let me give you one hint. You might see in your exam, this is Lighted Brains online tutorial, and we don't just teach you, we also share insights. Okay, because we've been there. Now, you might see in one of your questions, you might see solve this y is equal to 4x squared using first principle, and you will see option. If you are not wise enough, you will start using first principle to solve, wasting your little 30 minutes time you have. When you can simply use power rule, nobody will know if it was power rule you used to solve, or nobody will know if it was chain rule or first principle. What they are concerned about is arriving at your answer. Okay, so that's simply that. So for any CBT based exam, and they specifically told you to use a specific rule, first principle to solve, do the one you know is use the method you know is easy for you, that will give you the same, because it's the same answer you will arrive at. Okay, so this aspect, this section is just introduction to just explaining first principle, using first principle method. On our next class, we'll be talking about the product rule. Okay, now like I said before, this is Lighted Brain online tutorial, and we've been on the online space for some years now, for jamb, post-UTME, for 100 level students. We offer other courses. This is just mass 102, MTH 102. We offer MTH 101 course. We offer biology, your chemistry, your physics, even your physics practical will be explained as well. So do well to click on the subscribe button and hit the notification bell so that you can get notification when new videos have been posted. Okay, so thank you guys.